Hello students, it's me Saurabh Kumar, Physics mentor associated with AskIITians. About my educational credential, BTech Electronics, MTech in VLSI and Embedded Design from Delhi campus. Let's start with the topic oscillation. So first of all, we would like to discuss what oscillation is and what are the codes regarding oscillation. As we can see on the screen, life is a constant oscillation between sharp horns of dilemmas. Means there is a to and fro. Fluctuations occur in the ideas that comes under oscillations. And we can start with the Einstein statement. He discussed a theory can be proved by experiments, but no path lead from experiment to the birth of a theory. Of course, we can signify the mean. We can see the oscillations occur in the diagram. We can see oscillation can be seen over here. So we can say it is a type of oscillation occur. So it is just a practical phenomena. That's why we develop a theory of oscillation. In this way, we will switch to next slide. In the next slides, we are getting introduction part oscillation. What do we mean by oscillation? To and fro. One complete cycle of repetitive to and fro motion from one extreme maximum to minimum or minimum to maximum. Like that we can say. Means we can say there is a spring that execute to and fro motion. Now we can represent its graph. It is just a displacement graph that is with respect to time t. We can see here the amplitude as well as the time. So we can say it is just the displacement. We can see why is the displacement defined. It's the total time to cover for one revolution, and also it is just the wavelength. Now we can see its presentation over there on the graph, that is a relationship between energy and the displacement, because we must know energy is a function of force, whether it contains the type of phenomena like that means its energy get reduced to the minimum and then increases. So what we get to and from motion take place. So means it loses energy from coming from maximum to minimum and then minimum to maximum. That can be represented. Now we will switch to next types of oscillation occur. There are three main type of simple harmonic motion: free oscillation, damped oscillation, forced oscillation. So in case of free oscillation, we are getting simple harmonic motion with a constant amplitude and period and no external influence. I mean, we can say if no external force occurred to execute that to and fro motion, that comes under free oscillation that has constant amplitude and period. We can say amplitude is not changing, also its time is not changing, that comes under free oscillation. Second part, damped oscillation. Damped oscillation is simple harmonic motion but with a decreasing amplitude and varying period due to external or internal damping forces. Now, I would like to give you basic intro about damping. What damping is? Damping is an influence within or upon an oscillating system that has the effect of reducing, restricting, preventing its oscillation. What we are talking about? We are talking about restoring condition. We use the word reducing, restricting, preventing its oscillation. It is due to the restoring force. In physical system, damping is produced by process that dissipates the energy stored in the oscillation. And the example includes viscous drag in the mechanical system. We can say resistance in the electric or electronic oscillator system. So means it is just a frequency-based phenomena that restores and executes its motion, oscillator system. Now we can say damping is not based upon energy loss that can be imparted. Already we discussed energy can never be created nor destroyed, but it transferred from one form to another. In the case of oscillation, redistribution of energy takes place into mechanical to kinetic, kinetic to mechanical. But if we are talking about electric or electronic phenomena, we can say energy distribution takes place in that. So we define into four parts: overdamped, in which the system returns to equilibrium without any external effect; critically damped, the system returns to equilibrium as quickly as possible without oscillation. Third, underdamped. Underdamped, we can say the system oscillates with amplitude gradually decreasing. That comes under underdamped situation. And fourth part, we can say damped. means that oscillates with the natural frequency. So the four part: overdamped, critically damped, underdamped and damped. So these are the parts. So what? It is just due to the restoring condition. Now we would like to discuss the case of forced oscillation. In case of forced oscillation, the bass has simple harmonic motion. Why I am calling forced oscillation? Because it executes with the external force and there is restoring force that opposes the change in the motion. Also, the concept of inertia is involved in that system. And we are about to discuss this part, forced oscillation. Now, we can see the free oscillation over here. The amplitude remains constant as time passes. There is no damping. The system of oscillation will occur only in theory, since and practice. There will always be some damping. The damping can be represented by the formula y equal to a sin omega t. We must know y equal to a sin omega t. Actually, we will discuss this mathematical formula y equal to a sin omega t. Y is the displacement at any time t. A is the maximum displacement called as amplitude. Sin is the operator. Omega is the angular frequency. And t is the time instant. So we can say four systems: spring 1, 2, 3, 4, 5. Actually, these are the instant of system. It execute free oscillation where amplitude is constant but displacement changes with respect to time t, and it possesses some frequency. Now we will come to discuss example involved in the damped oscillation. So question is, what do we mean by damped oscillation? So damped oscillation. So actually damped oscillation, we can say damped oscillation, it is an influence. It is an influence within or upon an oscillating system that has the effect now main word of reducing, restricting, preventing its oscillation. So actually we are talking about restoring phenomena. In physical state, damping is produced by the process that is dissipated the energy stored in the oscillating system. So means dissipation is due to energy stored in the system. And the example can be under this. These are viscous drag in the mechanical system. We learn the case of Stokes law, that is just a frictional force. If there is a pan, there is some liquid, viscous liquid. If we drop any block into this, what happens? It executes a type of damping in which its amplitude is getting decreased with time. So these are the examples under this. Also we can say absorption and scattering of light in optical oscillator. So we can say damping is not based upon energy loss that can be important. Its type can be discussed as first type, overdamped. In case of overdamped, what happens? The system returns to the equilibrium. So we can say system return to equilibrium without oscillating. Second part we can say that is critically damped. May system return to equilibrium as quickly as possible without oscillating. And in the third part we will discuss about underdamped. So in case of underdamped, so amplitude decreases phenomena is same. The system returns to its equilibrium position but with decreasing amplitude. So amplitude decreases. And in the fourth part we can say, we would like to say that damped. So it is under damped. So means we can say natural frequency. So these are the examples involved, like overdamped, critical damped, underdamped and damped in case of damped oscillation, and it is due to the restoring force system. In this part we discussed about oscillation and its type, free oscillation, artificial oscillation, damped oscillation and their applications along with an example. In the next part we will discuss about periodic motion, SHM and kinematics of SHM. So stay tuned with us for the next part.